Good evening to all. Welcome to the today online class. Okay, today is the fifth class we are studying. Now, in the last class, the topic was C4, that is a study on the quantity of sewage. Study on the quantity of sewage, which is generating in a society. How to estimate the quantity of sewage? The Q is equal to Q1 plus Q2. What is this Q1 and Q2? Q1 is nothing but a dry weather flow, and Q2 is equal to wet weather flow. In order to find out a suitable size or a section for the sewer, it is necessary to determine the quantity of sewage. It is very important. If you know the quantity of sewage, how much it is generating in a society, then only we can able to design a sewer line. Okay. Now we have studied already the sewage can be determined by finding out. Number one is what actually dry weather flow. By knowing a dry weather flow, this is considered as Q1. Then wet weather flow is a Q2. Okay, dry weather flow and wet weather flow, if you add these two, then you will get the total Q, which is entering into the sewer line. Now, dry weather flow means it consists of again two types. That is a domestic sewage and industrial wastewater. Uh, if you add these two, you will get a dry weather flow. Next is the factors which are affecting the dry weather flow. Here there are four factors. You have to consider these four factors for the design of DWF. That is a dry weather flow. First one is infiltration and exfiltration, nature of industries, population, and rate of water supply. We have already discussed on the first one, infiltration and exfiltration. What is infiltration? The sewage. Okay, infiltration means the sewer line were laid below the ground level. Okay, the water which is entering inside the sewer, the water which is entering inside the sewer through the joints is called infiltration process. The process of entering the sewage, that is water surrounded by the joints, surrounded by the sewer line. It is going to join into this. So that this is addition. This is extra water is going to be added into this sewage. Okay, exfiltration means what actually? Here the water which is coming outside. This water which is coming outside. This is a Q. Which is coming outside through the leaky joints. The leakage of sewage. The leakage of sewage. Okay, the leakage of sewage through the joints. Okay, into the surroundings soil or surroundings to the sewer line. It is called exfiltration. Okay. Now we'll go to the next topic. We are already discussed on infiltration and exfiltration, and what is the difference between these two. Which one is desirable to consider for the design of sewers? Both are undesirable. Both are undesirable. Addition and also problem, and reduction also problem. So that these are the differences. You can study by looking into this. Okay, this notes. The quantity of infiltration is depends on the factors. Which are those factors? The infiltration and exfiltration. Okay, now we are talking about infiltration. This infiltration is having again four factors. Infiltration is having again four factors. What are those? To estimate the quantity of sewage. Okay, to estimate the quantity of sewage, these four factors are very, very important. Okay, number one is groundwater level. This is called groundwater table. Okay, second one is length of the sewer line. Third one is nature of soil and the type of soil through which sewers are laid. Okay, fourth one is size of the sewer. These are the important factors to be considered in the design of sewers. The particularly infiltration. Consider to infiltration. Infiltration means what actually? Incoming water can be estimated using these four factors. Now among these four, again we are to measure the quantity, to measure the quantity of infiltration into the sewer line. Again, we are having three ways of what you call expressing the quantity of infiltration. See, one is area, another is the length of the pipeline, another one is the diameter. Area means catchment area. See, observe here, very first one is A. Second one is L. Third one is diameter. See, let us study one by one. The first one is liters per day per hectare of area. See, observe here, liters per day per hectare of area. See, you are having some area. That area is a catchment area for getting the sewage into the pipeline. Now, this will be considered as A. See, okay, this area wise. See, and it will be expressing so liters per day per hectare. Okay. Now let us continue. See now this is liters per day per hectare of area. Liters per day per hectare of area. So many liters of water entering into the pipeline per day. Every day you have to calculate per day. Oh, remember it. The sewage is calculated or estimated per day capacity. Always. A sewage treatment plant also. See the LPCD. Do you know in water supply what is LPCD? LPCD means liters per capita per day. See, per day only we are supplying the water, so that you will get a per day quantity of sewage. See, that will go to the sewer, what do you call? That is sewage treatment plant. See, in the sewage treatment plant, capacity can be expressed only in terms of per day quantity. So many liters which is entering into the sewer line. Okay. Now, this is called the what you call? The first one is the area of the catchment. The catchment area will be considered. So many liters per day it is entering into the what you call pipeline. See, that will be what you call with respect to the area. Area means what actually? Hectares. So many liters of water it is entering into the pipeline per day per hectare of catchment area. Now, how to determine this A? This is a question mark because in the design they are going to ask all the things. Please remember how to determine infiltration and how to determine exfiltration and how to design the diameter of the sewer line. That is both are very very important. Now in this case, liters per day is a short form. This is a details. Okay, a flat allowance will be given with respect to the area of the location. See, location or a residential area. See, the area we have to consider. See, these are the houses. From here, the wastewater is entering into the sewage treatment plant, STP. Okay. Now, the example. The rate of infiltration. For example, this is a small problem. See, problem means it will give an idea how to estimate, how to consider the first, what you call the length per day per hectare of area. No, so how much water is going to be considered. See, for example, rate of infiltration is 10,000 liters per day per hectare. In 1 hectare of area, see 10,000 liters of water is entering into the pipeline per day. It is rate of infiltration going inside the sewer line. Now, the sewer serves an area of how much area it is going to serve? 20 hectares. See, 20 hectares, that is very very important. 1 hectare is equal to 100 by 100 meters. That is 10,000 meters square. That is the area. Now, the quantity of water entering into the sewer. This is an example. For 1 hectare, ನೋಡಿ 1 ಹೆಕ್ಟೇರಿಗೆ 10,000 ಲೀಟ್ರು 10,000 ಲೀಟ್ರ್ ಒಂದು ದಿವಸಕ್ಕೆ ಪೈಪಲ್ಲಿ ಎಂಟ್ರಿ ಆಗಿಬಿಡುತ್ತೆ ಹೊರಗಡೆಯಿಂದ. ಹೌದಾ? ಆ ಥರ ಇದ್ದಾಗ ಪ್ರಾಬ್ಲಮ್ ಹೆಂಗೆ ಸಾಲ್ವ್ ಮಾಡಬೇಕು? ವಿ ನೋ ದ ಏರಿಯಾ, ವಿ ನೋ ದಿ ರೇಟ್ ಆಫ್ ವಾಟರ್ ಸಪ್ಲೈ, ದಟ್ ಈಸ್ ಎಂಟ್ರಿಂಗ್ ಇನ್ ಟು ದಿಸ್. ಓಕೆ, sewer serving area is 20 hectares and then rate of infiltration is 10,000. So that if you multiply these two, so you will get the quantity of water which is entering into the sewer line. Here 10,000 into 20 hectares, you will get 2 lakh liters per day. 2 lakh liters of water is going to be entered into sewer line. Okay. See, next number 2 is liters per day per kilometer length of the sewer. See, length of the sewer is in kilometers. In with respect to that, number of joints are there. Okay, the liters per day per kilometer length of the sewer. See how to determine this. Here, for normal condition, the rate of infiltration may be taken as 15,000 to 75,000. 15,000 to 75,000 liters per day per kilometer length of the sewer line. Now, these are the actually what you call this. Simply, we are going to consider, see how much it is required, 15,000 to 75,000, the rate of water which may enter inside. Next, third one is what you call liters per day per centimeter diameter per kilometer length of the sewer line. You observe here, the abbreviation also I have given liters per day per centimeter diameter, okay, per kilometer length of sewer. So diameter is also very important and length of the sewer is also very important. Like this, so many liters will enter per day with respect to diameter of the sewer and with respect to length of the sewer. Okay, the logical way of expressing the rate of infiltration larger the diameter of the sewer, so the greater will be the amount of infiltration. You observe here, what is the meaning of this is larger the sewer diameter, the huge quantity of sewage is entering inside because joints automatically it will be enters through these joints. Okay. Next, now it is okay. We are completed the infiltration. How to measure that one? Now, according to this, infiltration and exfiltration is over. Exfiltration means you remember it is going outside means you have to deduct that value from the design problem. Okay, the Q during estimation of Q, what you have to do is you have to deduct the exfiltration, how much it has gone outside. Infiltration means we have to add into this Q value. Okay, now the second one you have to study, that is nature of industries. Nature of industries means based on the type of or nature of the water utilization in that industry is to be calculated. According to that only you have to estimate what you call the contribution of industrial sewage to the sewer line is very important. Okay, next one is the population. This population is the third one. Population is very important. That is quantity of sewage is mainly based on the population. Why means the rate of water supply is very important. The rate of water supply, how much your quantity you are giving to the public, okay, that much of wastewater is coming outside. See, this is the number one is nature of industries. Number two is population. See, the first one is infiltration, the exfiltration already discussed. Okay, now the population means the population forecasting is also you are studied, right? See, it is mainly depending upon the population and the rate of water supply. How much you are going to supply water to the public, that is very important. And what is the amount returns as a sewage. Okay, that is to be studied in this population topic. Okay, next the fourth one is rate of water supply. Rate of water supply means what actually? See, using quantity of, that is usually the quantity of sewage passing through a sewer line. Okay, the quantity of sewage passing through a sewer line is very important. So usually mainly based on the rate of water supply. How much water you are supplied to the public is very important. According to that, this rate of water supply is to be calculated. So usually what is the quantity of sewage and what is the quantity of water supplied to the public? Usually this will be little lower than the what you call the quantity of water supplied to the public. Always sewage quantity is a little lower than the quantity of water supplied to the public. Okay, now usually 70 to 80% of total water supply will be considered. Okay, now Q of sewage, therefore Q of sewage is equal to 70 to 80% means how much? 0.7 to 0.80, okay, into quantity of total water supply. See, you have to multiply with 0.7 to 0.8, and how much, okay, the how much the wastewater quantity can be calculated very easily. See, you must know the population, you must know the water supply. See, just you multiply with those two. Sewage is equal to 0.7 to 0.77 to 0.8. You have to multiply with the water supply quantity. Then you will get exact quantity of sewage which is coming to the sewer line. Based on the Q value, see, you are estimated now, based on the Q value, you can design the diameter or size of the sewers. Understood? Okay. Next, the this will also the factors rate of water supply is it also depends upon use of water in industries and the preparation of lawns, what you call lawns, park, etc. And then extinguishing fire. Extinguishing fire means for fire demand you are already studied. That is the fire hydrants. Through that fire hydrants, see, we are getting the water whenever the accident met with the accident of fire. Fire accidents are there, then only they will use this water. So this water will be along the what you call the main pipeline which is provided in the city. The particular zones are selected to provide this what you call the fire hydrants or extinguishing fire. And next is the leakage, etc. If you consider all these then we are going to design very easily by knowing the rate of water supply. And finally, I will come to know design of what you call dry weather flow is very important. Dry weather flow estimation is very important. It is a very simple. See how to calculate dry weather flow. See, the population into rate of water supply into 0.7 or 0.8. If you multiply with this, you will get the what you call the real quantity of sewage entering into the sewer line can be determined. Now in the bottom, see, wet weather flow or storm water. Okay, this is also wet weather flow is equal to Q1. It is Q1 or this is Q2. Okay, dry weather flow is Q1 and wet weather flow is Q2. How to determine this storm water? WWF means what actually? Wet weather flow, it is equal to storm water. This is Q2. Okay. Now you have to study in detail WWF. What is WWF? Why it is so called Q2? That means storm water. See, wherever it is possible, the storm water is to be collected and conveyed into the sewers at proper places. Okay, remember it. Otherwise, simply you cannot neglect everything. See, this is a storm water. Storm water also determined. That is called WWF. You know already. See, the storm water can be determined using standard equations. According to that, you have to what you call study on this. The quantity of storm water which is known as wet weather flow. Okay, agree. And the mentioned as and is mentioned as WWF is to be carefully measured. Is case to be measured. See, according to this, WWF is a storm water that is called Q2. It can be measured by means of some important what you call methods. See, what are those methods? That is also very important. See, observe here. This WWF is involves various factors. Number one is intensity of rainfall, and number two is characteristics of catchment area. Number three is duration of storms, and number four is meteorological factors. Meteorological means that is havaguna, havamana anta karitivalla, that is okay. Totally four factors to be considered in the determination of what actually the WWF, wet weather flow. Now here, coming to here, the methods used to estimate the quantity of storm water, that is storm water used in the design of sewers. Okay, now the WWF can be calculated WW can be calculated or estimated by using these two formula. This is a what you call rational formula method. Another one is empirical formula method. Rational formula method and empirical formula method, both are to be, you have to know the examination. These two formulas are very, very, very important. Even design also, they will ask either by rational method or empirical formula method. Empirical formula, we are having around 6 to 7 equations are there. According to this, boil it and use that equations for the estimation of what actually velocity. Remember it. Rational formula method, Q is equal to AV, right? A is available, V is velocity, and Q is the discharge. Now let us go to what you call methods used to estimate Q2. Q2 means storm sewage. Okay. Before going to this storm sewage, see, you have to use a rational formula method. Rational formula method means what? Why we have to study this? Okay, that we are going to study in the next class. Okay, see, find out the runoff. Find out the runoff from the area. Okay, runoff from the area. See, this is actually storm sewage which is flowing on the ground surface. See, we want to estimate the what you call the measure of want to estimate the measure of what you call rational formula method. From what you are going to measure, it is a Q value. Q is equal to AIR. This is also one formula, and Q is equal to ORR. Q is equal to K into AIR. ORR Q is equal to AIR. Q is equal to AIR divided by 360. See, these are the three varieties of formula we are going to use for the what you call wet weather flow. See this how there is a definite question on this. They are going to ask one bookwork. So bookwork is very, very simple. Only thing is we have to calculate what you call the dimensions and all, and simplify, that is solving that one. You will get the what you call what is the diameter, that is what is called the Q value can be determined using this. Okay, today I am going to stop at this stage, and then remaining we are going to study in the next class. Okay.